This is an example problem of finding the battery terminal voltage for a battery with internal resistance when it's connected to various resistors. Okay, so in this problem, we have a battery that has an EMF of 5 volts and an internal resistance of 1 ohm. So the question is to find A, the terminal voltage if no current is being supplied, B, the terminal voltage if the battery is connected in series with a 10 ohm resistor, C, the terminal voltage if the battery is connected in series with a 20 ohm resistor, and D, the maximum current that can be supplied by the battery. Okay, so first of all, we'll draw a sketch of the battery, which I've already done here. We have this battery, which nominally is a 5 volt battery, okay, which means that it has an EMF of 5 volts, and it has an internal resistance of 1 ohm. So you can think of that as having the power supply part of the battery and the internal resistance of the battery kind of drawn separately inside the battery like I've shown here. So first of all, to find the terminal voltage if no current is being supplied, well, by definition, the EMF of a battery is the terminal voltage if no current is being supplied. So the answer to part A, we already have, that is 5 volts. Okay, because if you were to put a voltmeter here and measure the terminal voltage when no current is being supplied, then we would get 5 volts. Okay, but what about part B? What's the terminal voltage if the battery is connected in series with a 10 ohm resistor? Well, let's draw that circuit. So here is the power supply part of the battery, the 5 volt EMF. Here is the internal resistance of 1 ohm. Okay, and you can kind of think of the battery. And I'm not going to draw the physical battery, but you can put sort of a dashed box around the part of our circuit that represents the physical battery. Okay, so that the positive terminal of the battery is right here at that dot, and the negative terminal of the battery is down at the bottom of that dot. Okay, so in our circuit diagram, we need to go ahead and connect the 10 ohm resistor. And it's in series, so you just have to connect it like that. Okay, now what is the terminal voltage of the battery? That means we're going to put our voltmeter, I'm going to switch colors. So let's put our voltmeter here and here so that we're measuring the voltage between the positive terminal of the battery and the negative terminal of the battery. So this question is asking, what's that voltmeter? What's that blue voltmeter going to read? Well, if this were an ideal battery, it would still read 5 volts, but it's got that 1 ohm internal resistance in there. So what we need to do is we need to find the current that's flowing in this circuit and figure out how much voltage drop we're going to get across that 1 ohm resistance and subtract it from the 5 volts. So let's do that. Let's use Kirchhoff's rules, the loop rule, in order to determine the current through this circuit. Okay. All right. So we have, let's start here at the negative terminal of the battery and go around the loop of the circuit in a clockwise direction. So we do that. We come up to about here. We go, let's see, I've drawn that battery backwards, haven't I? I need the positive terminals here, and the negative terminals there. That's better. Okay, so when we go from the negative terminal of the battery to the positive terminal of the battery. That is a voltage increase of 5 volts. I then go across the 1 ohm resistor in the direction of the current. That is a voltage decrease of the current through that resistor times the resistance of the resistor. Then I go over this resistor also in the direction of the current, so that's a voltage decrease of current times resistance. And then I'm back where I started. So when you add up all of those voltage changes, you must be back where you started, so it's equal to 0. Okay. So you've got then 5 volts minus I 1 ohm minus I 10 ohms equals 0. That means 5 volts equals I times 11 ohms, or I, the current in the circuit, is 11. It's 5 volts minus 11 ohms, and that is 0.455 amps. Okay, now, okay, that's the current flowing through the circuit. So if I have a current of 0.455 amps flowing through this internal resistance, how much of a voltage drop am I going to get inside the battery? Well, the voltage drop inside the battery is going across the internal resistance of 1 ohm. It's going to be the current times that internal resistance, lowercase r. So that will be 0.455 amps times the internal resistance of 1 ohm. I have an internal voltage drop inside the battery of 0.455 volts, which means when I measure the voltage drop with my blue voltmeter here, then I'm not going to measure the full 5 volts. I'm going to measure 5 volts, the EMF, minus the internal voltage drop of 0.455 volts, so that the terminal voltage, the voltage measured by my blue voltmeter, is going to be 4.55 volts. And that is the answer to part B. Okay, I'm going to, now let's do part C. What's the terminal voltage if the battery is connected in series with a 20 ohm resistor? Okay, so we change colors again and keep from getting confused. Okay, so now we're going to replace this 10 ohm resistor with a 20 ohm resistor, and I want to find the terminal voltage. Okay, well, we'll use exactly the same procedure that we used before, of course. We will start here, walk clockwise around the loop of the circuit, and we'll have an equation very similar to what we had before. We have a 5 volt increase when you go from the negative terminal to the positive terminal of the battery. We need to subtract I times 1 ohm when we go over the internal resistance. We subtract I times 20 ohms when we go over the 20 ohm resistor. We're then back where we started, so that's 0. 5 volts equals 21 ohms times I. So this time, I is equal to 0.238 amps. And the voltage drop across the 1 ohm resistor inside the battery is 0.238 volts. That means the terminal voltage, the voltage as measured by the blue voltmeter, will be 5 volts minus the 0.238 volts, or 4.762 volts. That is part C. Okay, so let's discuss these answers for a moment. Okay, first of all, you see that the voltage, the terminal voltage of the battery, depends on what kind of resistance is connected outside the battery. Because the more current the battery tries to supply, the more current will be flowing through its internal 1 ohm resistance, and the bigger the internal voltage drop will be on the battery. So, ironically, the higher the current that you try and get out of this battery, the lower the terminal voltage of the battery. The highest terminal voltage is if you don't try and get any current out of it at all, 5 volts. When we only pull 0.238 amps of current out of the battery, then the terminal voltage is 4.762 volts. But then when we tried to get the battery to supply 0.455 amps, then the terminal voltage dropped even to 4.55 volts. So, what's the maximum current that can be supplied by this battery? All right, I'm going to erase what we have worked out here since the whiteboard is getting full. So pause and write this down if you're not finished. Okay, so what is the maximum current that can be supplied by the battery? Well, the maximum current would be if we didn't hook any extra resistance to the battery. The maximum current would be if we just took the battery, and don't try this at home, because the battery will get hot if you do this, possibly even catch on fire if it's, depending on what kind of battery it is. Okay, here's our negative terminal and our positive terminal. Here's our 1 ohm internal resistance. So the maximum current that we can get out of this battery would be if I just took a wire and I connect the bottom of the battery to the top of the battery. Let's see how much current I'm going to get in this case. Okay. So once again, we'll use the loop rule. We'll start right here, and we'll walk clockwise around the battery, keeping track of all voltage changes as we go. There's going to be a current flowing in that direction. Okay, so when I go from the negative terminal to the positive terminal of the battery, the internal part of the battery, I have a voltage increase of 5 volts because that's the EMF of the battery. Then I go over the resistor, 1 ohm, and then I'm back where I started. Okay, so we now have 5 volts equals I times 1 ohm. I is equal to 5 volts over 1 ohm, or 5 amps. That is the answer to part D, the maximum current that you can get out of a battery that has an EMF of 5 volts and an internal resistance of 1 ohm.